like to introduce Joseph Nicholson. Joseph is a network operations engineer at NTT Data and traveled from Dallas, Texas to join us today. This is Joseph's second time presenting with NANOG, and it's a pleasure to have him speaking to us today. Welcome, Joseph. Oh, and the title is the Scaling Network Operations with Modular Ansible. That would help.
Thanks, man. Appreciate it. Good afternoon. I hope everyone's had a great NANOG. Over the last couple of days, I was talking to somebody, and we came to the conclusion it felt like this room was weirdly a little bit smaller than normal, but I assure everybody from up here, it is endless, and there's thousands of people out there. So it's definitely not smaller. All right, my name is Joseph Nicholson. I'm with NTT Data. So I'm going to really quickly tell you a little bit about myself. This is not an existential exercise. I'm not going to keep you here all night. I know we are very close to being done for the week, but I've been a network operator for about 26 years now. I've been with NTT Data for roughly 18, almost 19 years. 12 years of that was on the NOC team, and in the last 7 years, I hit this anniversary a couple of weeks ago, I was hired into the network operations team, and about a year ago, we reorged, and I was brought into the network scaling team. And my primary day-to-day focus is on network automation. A little bit about NTT Data for those of you who don't know us. We're a Tier 1 transit provider. You may know us better as our ASN 2914. Our network spans 5 continents, 40 countries, and 90 POPs. We offer IP transit, virtual link, global virtual link, and DDoS protection services. Our port speeds are 1 gig, 10 gig, 100 gig, 400 gig. We have about 800 network elements across that we're responsible for. About 250 of those are backbone routers. Another 100 or so are DWDM. Those are the two types of devices I work on primarily for automation. And here's a bit of a view of what our network looks like. It does span the globe. Before we get going, I'm going to give a little bit of a disclaimer. I'm explaining how Ansible works for us, how we got it working to begin with, and how the modular task system works. There are a bunch of different ways to do this. I understand that. After I gave this presentation last time, a couple months ago at AutoCon, I had a bunch of people come up to me and give me some suggestions and help me out, and I had to redo the deck a little bit to account for some of those changes. So I'm more than happy to take feedback later on if you guys want to, or if you're in the Q&A portion, come tell me how I'm doing it wrong. That's the only way any of us are going to improve is by getting experience relayed to us from other people. Change is hard. I got down the rabbit hole in this one, and it's been hard to dig myself back out. So like I said, we can do things better, but it's hard to steer that ship a different way sometimes. And I know that some people are going to tell me my task files are too large. Don't worry, I don't show you any of those, but they are, and I get that, and we can break them down a little bit more, I think. The way we use Ansible is whenever we have a router process based on an existing method of procedure or MOP, that's when we use Ansible. Usually if the human is going to sit there and type things into the CLI, that's when I want to use it. Otherwise, I'm using Python to do everything else. And generally with Ansible, it's only a start to finish process on a particular device as opposed to many devices. We are using this primarily, well, not primarily now. It's about 50% of it is done in the CLI now on a jump server. The other 50% is done via AWX. We started out with the CLI. A lot of our engineers and technicians are comfortable with the CLI. They're very good at using Linux and stuff like that. Also at the time, I was learning Ansible from scratch. I didn't have time to learn an orchestrator at the same time. Pretty sure everybody can understand that throwing too much onto you, you're not going to get anything at all done. So, and every user, this was done through a repository, so every user had a copy on their home directory. That is not the best way to do it. I wish I had not done it that way, but here we are. The AWX transition has started. I'm slowly migrating the playbooks off of the CLI into AWX, so some of what you're seeing is going to be changing. If I were to give this a year from now, I would expect it to be greatly different. And then from day one, all new playbooks will live in AWX. So, all right, I'm going to go over our repository for a little bit here. This is our Ansible playbook overview. On the left-hand side, you can see that we, all the playbooks that ran manual in the CLI still are router software upgrades. Update traffic, that particular playbook is the one that we use if we need to do something where we need to take traffic off the router and then put it back on afterwards. That's what that playbook will do. Circuit testing, our customer engineers use that to test the circuits once they're hooked up before they're handed off for installation and usage. And then, well, configuration and usage, not installation. And then our post turn-up checks for our routers are all done on the CLI still. In AWX, we're running vendor TAC collection. This is a playbook we use that when we need to open up a TAC case with Cisco or Juniper or whoever, we can run this, collect all that data that they're going to ask us for, and then throw it on the ticket immediately. Software package management, it runs every week, keeps the latest qualified version of the image on the routers. Every RE, every RSP, they're all there. And then some maintenance snapshots, pre, post snaps are now done through AWX as of a week ago fully. And then optical software upgrades. That one has an asterisk. I have done the first couple of tests into AWX. I found some issues. I get to go back next week and work it out. So that one's still in flight, but we're almost there. Repository itself is named Operational Ansible Playbooks. I strongly suggest you have a naming policy because trying to say that a bunch of times in a meeting is gets annoying. This is a GitLab hosted repository. It does have a few CI/CD pipelines across the branches, and it does use a custom runner. This runner has access to the network, so we make sure we have it secured so that nobody can use it unless they're allowed to. The repository has 5 main branches. It's got the main branch, which is where all of the CLI-based playbooks are ran out of. The AWX branch, which is cloned over to AWX Orchestrator, and those playbooks are ran from there. The AWX EE build is the execution environment branch, or the branch that builds the execution environment for AWX. And then the inventory for AWX is its own branch. And then the AWX management is a new branch that I put together in the past few months to help me build up an AWX server from scratch and get it all configured in a few minutes, as opposed to me spending half a day making it work because I can't remember what I did last time. The main branch file structure or folder structure looks a little bit like this. I took a bunch of the ancillary stuff out, but I wanted you guys to see the primary here. You can see that all the playbooks are listed at the bottom, and they all run out of here. Today we're going to really focus in a little bit on the main branch task folder, but I wanted to kind of show it holistically what everything sort of looks like here. The subfolder structure for all the folders, not just tasks, even though that's what this one looks like. Tasks and scripts look a lot like this. The subfolders are all named after the playbook itself. So you got circuit testing, collection for vendor TAC collection, maintenance snaps, post turnups, router upgrades, shared, software management, and update traffic. They're all subdivided into individual network operating system folders so that they're all kind of grouped together under their own NOS. I don't have to try to figure out what's Junos and what's SROS and so forth. It's all just kind of there in the folder structure and kind of keeps it in place. And the shared folder is just a bunch of tasks and task files that are not specific to any NOS. Those are generally going to be tasks that don't actually take place on the router, but they're local or they're doing something with another system, such as creating the folder where the log file lives, or creating the log file itself, or doing a ticket check against ServiceNow to make sure the correct ticket number is being used, and so forth. And looking at this is a newer slide that I put in recently where AWX root folder structure, you can kind of see how it's changed compared to the CLI version. The playbooks now are all running as roles for the most part. There are a couple of instances where some of those task files need to be shared across roles, so they're still task files as opposed to being rolled up in the roles. And I noticed this the other day, but past Joseph, he's kind of a pain in my backside, and for some reason, I don't know what his reasoning was, but he decided that the playbook folder was legacy in this branch. It very much is not. all of the playbooks are held in the playbooks folder, and they call the roles from this particular branch. So I'm going to have a talk with that guy when I get home and figure out what he was thinking. All right, the subfolder structure looks very similar. There are fewer folders in the subfolders in the task folder because I haven't converted everything over yet. But also, like I said, most everything is in roles now. They're under their own contained roles, and they don't need to be in the task folder specifically. So you can see it's kind of shrunk down a little bit there. Talking about the CI/CD pipeline, the main branch has 2 pipelines that it can run. When I do a merge request, there is a fix me pipeline. This is to prevent my mistakes from going into production yet again. There's been instances where I want to disable some parts or tasks and I want to run the whole thing. I don't want to run through everything. I just want to run a portion of it, and I'll disable things here and there and put a fix me tag on there. And if that fix me tag is found or comment is found in anything, the merge request or the merge stops immediately and alerts me that there's a problem, so I can go figure out what's going on. And then the AWX updates for the router upgrades and the software management. What I have is a OS revision variables file that holds all the latest information, such as the latest OS version, the file name, the location of the file name on the file system, and all that. That is replicated. Once that file gets updated and the pipeline sees that, it'll merge that into the AWX branch and then kick off the AWX API to pull that file in. So the next time we're doing software management updates every week, AWX will go update all the routers. The AWX branch itself just has some Ansible and Python linting and syntax checks at this point. It's not doing much of anything else in the pipeline. The AWX execution environment build pipeline, it allows us to generate new images as test images. I can pull those over to AWX. I can do all my tests. I can make sure everything works the way it's supposed to work and not affect production. And then I could promote those images to production after I'm done with my testing from the pipeline that's still waiting for me to tell it to keep going or stop. And if I find any problems with those images in production later on that I didn't find in testing, I can also go back in there and revert that old production image back into production and pull this one back out using that pipeline. AWS inventory, that runs on an hourly basis on a schedule, and if there's an update to the inventory, it will generate that new file, put it into, commit it to Git, and then trigger the AWX API to go pull that new version, and then trigger it again to commit that version into production and start using that inventory system, or that new inventory file. The AWX management, there is no pipeline for that one at this time. All right, so get into modular tasks. What are task files? Task files are a collection of tasks to perform a process. It's pretty simple. You should really, I recommend you keep them on task. I know that's a terrible joke, but it seemed funny at the time when I wrote it. Who knows? You can run, I like this because you can run task files in one playbook and you can call them with other playbooks as you need them. You don't have to keep redoing the same tasks over and over again. I mean, it's very simple. It's a lot like, I mean, I think most of us are hopefully familiar with Python. It's like using a modular function in Python. That's the same concept, at least in my opinion it is. When task files are called, they'll just run their task to completion and then go back to the main playbook from where they're called from. I like to think of it as a little bit of a branch on a tree. It kind of goes off. And sometimes that branch will branch on its own and do some more things, but whenever it's done and it gets to the end of the branch, it just goes back to the trunk and just keeps continuing from there. You don't have to tell it to go back or anything like that. Today I'm going to run through the example of router software upgrades. I'm going to show you how the upgrade playbook will use tasks from the software upgrades, software management and maintenance snapshots, and traffic updates. This is not a thorough step-by-step account of every task in this procedure. It's not meant to be. Just want to kind of show you how you can use task files from other playbooks in the existing playbook wherever you need them. If it were a thorough step-by-step, I would be here much longer than 45 minutes. So I got a visual representation of the main playbook and the tasks folder. I think it's kind of hard to see, unfortunately, but the tasks on the right-hand side are all covered by a box with the task labeled above it. And you can see that each individual subfolder, shared, router upgrades, maintenance snaps, software management, and update traffic are all represented there in different colors, and you can see how the playbook will call them as needed. And we're going to step through this really quick, we're going to step through this for a few minutes and talk about it some more. So the main playbook, the router upgrade YAML, it will start off, it'll come in, and the very first thing it does, which is not on the slide, but it'll ask for a ticket number. And the technician will give it that ticket number, and it will take that ticket number and it will take the host name that's been given to it, and it will run the ticket check, and it'll verify in ServiceNow that that router name is associated to that ticket number. That's one of our safeguards to make sure we don't upgrade the wrong thing by accident. If they don't match, it stops immediately and we're safe and we haven't annoyed anybody during that particular window. Then after that's done, it'll go through, create the log file and a log folder, and then it will step back out to the router upgrade file itself and start going into the router upgrade folder. And from there, it'll call a vendor-specific router upgrade YAML file, which in turn goes into the vendor folder and calls a pre-maintenance file for that vendor. That vendor's pre-maintenance file we'll call the maintenance pre-snaps. Once the pre-snaps are all ran and collected and put onto the disk, it'll do a software management check. So I've got a special check in there. Even though every week the image is being put onto the router and being verified that it's there, I have a special check in place just in case it's not there for some reason. The playbook will go look, is the right one there? Yeah, it's there. If it's not there, it'll download it immediately and get it ready and get it prepped for installation. So small little check. Most of the time that one doesn't run, but it's there just in case. And from there, we go back out to the router upgrade, the main router upgrade file, which will in turn call the maintenance file itself. And that maintenance file will go and call update traffic to shut down traffic on the router. And then it'll do all its fun things like upgrading, rebooting, verifying that it came back up, upgrading satellites, upgrading FPDs, any other firmware that needs to update. And then at that point, it'll call the turn up traffic file and start turning traffic back on the router. And from there, we get into post-maintenance, and we'll get the post-maintenance snaps. All the post-maintenance snaps will be collected. They'll be diffed against the pre-maintenance snaps. They'll be double-checked and verified to make sure everything looks the way it's supposed to look. And then we'll kick all the way back out to router upgrades, and we will finish up whatever we need to finish up in the particular process for that. So when we're doing and calling task files, there are two main ways to do this. We can do include tasks, or we can do import tasks. Include tasks are dynamic reuse. Those task files are processed as they're encountered through as the playbook's running. The import is a static reuse. When the playbook runs, anytime any of the import tasks are listed, it'll process those at the beginning. And that's important to understand, because if you're doing things where, like when you're doing router upgrades, for example, we know that, I think everybody, hopefully everybody in this room has run across this, where the router does something completely unexpected and your process stops and you don't know what's going on and you have to scratch your head. Well, that still happens even if you're automating things, because routers are unpredictable. And sometimes you need to restart it. And there's a start at task feature, so you can just give it the task name and it will skip ahead and restart that task. If the task is an include task, it won't restart at it because it's not pre-processing that and it doesn't know anything about it. So the import task is very helpful in this regard, so that you can go, hey, I need you to restart at this particular step, and it'll, since it's pre-processing everything, it's like, oh, I know that one, and goes right to it and starts from there and picks up where it left off. Those task names need to be unique for this to work. I'm in a particular scenario where I've got multiple options for check router connectivity. And if I just left them 3, whether it's Junos or SR or iOS XR or SROS, and just left it as, check router connectivity, the first one it finds, it'll try to use it, and it doesn't matter if it's the correct one or not. So I've had to name them as SROS check router connectivity, iOS XR check router connectivity, so on and so forth. So you put the correct one in there, it'll jump to the right spot. When I go back to AWX and I start importing this over, I'll be making those as individual roles, so I kind of get rid of that problem. But it worked for me 3 years ago. So for the, if you're going to use keywords, loops, conditionals, stuff like that, that's where include tasks kind of comes into play. A lot of times you don't have variables whenever Ansible is going to process those files. So if you try to give a variable to an import task that has not yet been defined, it'll fail because it doesn't have everything it needs to understand what's supposed to be done with that particular task file. So that's where include kind of comes in. You can give those to that, and by the time it starts to process that included task, it would already have the variable for it at that point. So, and if you're using keywords, loops, and conditionals, they only apply to tasks inside the imported task file, you're not going to loop through the imported task file itself. That's what that last one's about. All right. So I learned a lot of lessons doing this. I only have a couple listed here because I didn't want to take all day talking about all the things I learned while doing this. But I like this process because it allows me to update one playbook and then I update all of them. Anywhere those tasks are used, they get updated immediately. I don't have to micromanage and try to remember where I did that task in a bunch of different places. The bad part is if I break one of those playbooks, I'm going to break all of those playbooks. So you got to be kind of careful with that and test it and make sure. And I've had instances where I thought everything was going to be good and I go run a third or fourth playbook and for some reason it doesn't jive with that one. And I have to figure out what's going on and why that's happening. Usually it's my bad, but you live and learn on those things. Yeah, CI/CD pipeline itself, I was forced to learn more advanced usage to use that pipeline. Filtering changes across branches was something that was really difficult for me to understand and get around my head, but I finally got there. And it also, using it to find the fix me and prevent those common, oops moments and stuff like that. That was really powerful for me because I kept running into that. I was like, what am I going to do about this? And I was like, oh yeah, I got a pipeline. Let's use that. And so being able to do something that obviously I can't get out of that habit. I've had trouble getting out of that habit. So being able to build a pipeline to help me break that habit and to hold myself more accountable and prevent those things from happening is really powerful and really helpful. Also learning to use the pipeline to manage across branches, whether I'm going from development to production and learning how to do merge requests and such, or I'm pulling things from the CLI version to AWX version with the OS revision files. That was really helpful as well with the pipeline. And then the Groundhog Day scenario is what I like to call it, but I wish I would have adopted pipeline and API, the AWX APIs earlier. There were several instances there for a while where I was taking that OS revisions file every time it updated and copying it over to the other branch myself and updating the AWX manually and so forth. And there's other files I had to do that too as well. Every time an inventory would update, I'd have to go try to do all that manually, and that was a real pain. And so not doing that earlier is something I kind of wish I had done. And then again, better repository naming. Saying operational Ansible playbooks, 10 times really fast in a row, it feels like Groundhog's Day, just, repeating that over and over and over again. And I wish I had named it something a little bit smaller, like Ansible or Ansible Plays or whatever. But it is what it is. So at this point, I finished a little bit earlier than I anticipated, but thank you for your time. And if you have any questions, comments, or fun times, I'm here to listen.
Hello. All right. Chris Clark from Sandia National Labs.
Mm-hmm.
You kind of touched on it briefly at the end. It's a little off of your main topic, but one of the things I was curious about is manage your inventory, and also, how do you manage credentials? Like you mentioned, like operators are touching it. Are they putting in their credentials, or is the credentials stored in the inventory? How are you approaching that problem? And you also you had it linked into your ServiceNow and things. So is the inventory centralized, or are you managing that by hand?
Yeah, actually, funny enough, I gave this presentation at AutoCon a few months ago. Chris is behind you; he can vouch for me. I had a whole section on the inventory talking about that, and then I made a bunch of changes to the to the deck. And I was like, I got to take some stuff out, or it's going to be too long, and obviously not. But I was going to do a lightning talk this week talking about the inventory. But so the inventory itself is we have our own change management system. This is a system we've built and been using for 25, almost 30 years. And that has an API and all that good stuff with it. And so it goes in and just runs the API query, pulls out everything I want, and then puts it all in a YAML file and gets it ready to go. For the AWX version, pulls that across and installs it. For the CLI portion of it, every time a user runs a playbook, the Ansible config file points to the folder for the inventory, and there's a Python file in there that runs, and it's just dynamic. It runs immediately. It takes a few milliseconds. Again, I only have about 800 devices, so it's not. It doesn't take very long. They don't even notice that there's a latent lag to generating the inventory itself in memory, and then it builds all the groups and everything else that it needs to do. So all the information we need is pulled into there, and it's sitting in memory ready to go, and I will pull it out. Like if it's this platform, if it's this OS version, if it's this or that or whatever, if it's running MPLS, whatever it needs, it's all in my database, and I just grab all that out. As far as credentials go, in AWX it has its own credential store. I wanted to use, on the CLI, I wanted to use Ansible inventory, or not Ansible, Ansible Vault, but was going to bring a complexity that I was not sure how to work around, because every individual user would have to set up their own vault. And I think we can imagine how that was going to be, with my users are advanced. They're comfortable with the CLI, but I didn't want to throw too much new at them. They were already trying to understand and come to accept using automation as far as Ansible goes, because Ansible's a little bit of a black box. You don't always know what's going on, and things are flipping across the screen. So, but we do have a method of pulling passwords, which is local to each user, which we use for other functions, and we'll use that. And every user has access to like the ServiceNow API and stuff like that with their own credentials. So we do it. But I can talk to you more about that offline afterwards if you want to. So.
Wes Hardiker, Google, and also lover and hater of Ansible at the same time. Can you talk a little bit more about how you handle with error conditions? It's great when it all runs fully through, right? But you hit those error cases where one host fails in the middle, and then you try and rerun it, and an earlier task, taking traffic offline or whatever, fails for a different reason, and it gets really complex when you get into those cases of having to rerun it many, many, many times because of one weird case. As you said, routers are unpredictable, right? Absolutely, and I'm not going to get into the existential questions. I might get into a little bit of philosophy here, so bear with me a second. But I take the, this is me, not NTT talking, but I personally like the idea of the Toyota production system, Jinduko, which is automation with a human touch. If the automation breaks, we'll go in and I want to figure out what's going on, and I want to understand why it broke, and I want a human to be involved in that process of grabbing that data for me and whatnot. Sometimes they can just restart it and it'll work again, but I want to understand why it stopped in the first place. And if I can, I will figure out, okay, what can I do to prevent that stoppage? Or did that stop for a reason that's just one of those random 1 in a million chance things? Or is this repeatable? Is this something we can do something about? And if it's repeatable, I will figure out a way to build a fail and a rescue block to recover from that particular one. I actually had a Juniper bug. I got plenty of time, so I can go on stories here, I guess. I actually had a Juniper bug where in their Junos PyEZ module, it would go through whenever you're telling it to run commands. So the command of deactivating all the protocols and stuff, which we had to do, it goes through like 5 steps. And each one of those steps has a check, like put it in, verify that it went into candidate, verify that it's going to be accepted by the OS once it's committed, and then 2 other steps. And the final step of commit, that one had a bug in the fact that if you gave a timeout on the task and said, I need a timeout of 60 seconds, because I got a global network, I have latency, and the default 10 seconds isn't going to work in most cases. So I gave it a timeout of 60 to 120 seconds in a lot of these cases. If you give it a timeout on all 5 of those steps, 4 of them will take that custom timeout. That last step commit won't, and Ansible will time out at 10 seconds. The router's still going, doing its thing, but Ansible's like, oh yeah, it broke, and it'll fail. So the fix was create a rescue to do the exact same thing again. And by the time it got to the point where it committed, the router was already done, and it'd go, oh no, idempotency kicks in, and we're all good, right? So I try to figure out, like, okay, is this something we're going to repeat, something we can work against, and so on and so forth. And now that I've gotten, it's easier to do that on the CLI, in my opinion. When you get into AWX, where there's less flexibility, it's going to be much harder. So I cannot wait till we upgrade our NCS devices using AWX, because there's going to be a lot of long nights. But I'd like to keep the human in the loop on that, I think, is the short answer you were looking for. Is, I don't believe we should automate away everything just because we can. It sometimes helps to keep people involved. So is that?
Yeah, no, that's good, thanks. And we have a habit of only running Ansible when a human is in the loop for the same reason. So.
Yeah, exactly. Mr. Grundeman.
Hello, Chris Grundeman, man of many hats. One of them is not as an Ansible expert. So this is going to be very pedestrian compared to the last 2 questions, and maybe an ignorant question. But I was just watching, as you set up the files, right? So I get the different repositories you're using for all the Ansible playbooks. And in the main, you have it broken out by task and then by vendor. And I mean, that seems to make logical sense. That's definitely the way as a human I would think about it, is as, what am I going to do? And then what do I have to do it on? And I'm just wondering, I don't know enough about the way Ansible works or AWX works. Is that like actually a requirement, or is that a design choice? I mean, could you do like the other way around and have the folder for the device and then tasks inside of that? Or would that break things? Or is it just does that matter at all? Like the file structure as you have it laid out?
Well, I gotta go through all these transitions now. Actually, this is perfect. Huh?
There it is.
Oh, there it is. Okay, good. I didn't even realize it wasn't up there. So one reason why I did it this way, and I think this is really good, is I have vendor in the little curly braces, right? Well, I don't tell it to use Junos_pre_main.yaml. I tell it to use in curly, double braces, to use Ansible, or to use my custom vendor variable instead. Okay, and pre_main, and then have the file names there. So I'm not hard coding it in there. It's going by my variable that's in. That's the reason why I kind of did it in this way. I think you can do it either way. It depends on whatever works for you and how you set it up. To me, this seemed very logical when I did it, and now I'm sitting here 3.5 years later on stage talking about it, and I think it's pretty obvious. And I actually found some documentation before AutoCon on the Ansible website explaining how to exactly do this. And I went, oh, I'm stating the obvious, I think. But to me, this felt very natural, being very ignorant with Ansible itself when I first started. And it seemed like the way to go with it. But I think you can do it either way. It just depends what works for you and what's comfortable to you.
Cool, thanks.
So, yep.
Got a couple of online questions.
Ooh, awesome.
Tim Strobel from OmniFiber asks, is there anything you haven't been able to accomplish with Ansible?
Yes and no. There's a lot. I think you can do almost anything with Ansible. I think there are some things that are easier with Python. Early on especially, I got really frustrated trying to do certain tasks with Ansible, and I just went and wrote a Python script and called that script with the Ansible playbook and did it that way. Some of those I've gone back and converted them in. As I start to move things over to from the CLI to AWX, not only am I converting those playbooks into actual roles, I'm taking a lot of those common tasks and I'm making collections out of them, which essentially is just a Python file that
is called with the custom task on the front end. So I'm starting to do that myself, but I still think sometimes that Python's easier to use, and I think that's okay. Whatever works for you. You know, it's all iteration anyway, right? So if you can't get something working in Ansible because it just doesn't work, or you don't understand, or it's not doing what you expect it to do, or there's a bug, do it in Python and call the script. It's fine, or do it in whatever programming language you want. So.
And thank you for that. And we have another one from Daryl Newcomb, unaffiliated. Great presentation and work. What name did you end up moving to from operational Ansible playbooks? Antops or? I
have not moved to any other name. I just recommend thinking about that when you start, because my goal was to have a very descriptive name that made sense without having to go explain to anybody what it was. And I accomplished that. But in the interim, I've learned and decided that there is a description field on all these repos and everything you can think of for a reason. So fill out the description and people can figure out what the repo is for by reading the description as opposed to relying on the name itself. So.
All right, thank you, Joseph. It was a great presentation.
Thank you very much.
Appreciate it.